Good morning, Algebra 1. So today you actually have another collected only assignment, but I will say it is very important that you follow along and sort of understand what we're doing in the assignment today, because it does have a lot of bearing on future assignments. We're going to be looking at what types of real-world problems can get you a quadratic equation, or that we can apply our knowledge for. And I will say it's a bit tough virtually. It will be a bit tough to sort of wrap your mind around, so hopefully we can do it pretty well, and hopefully we can just stay on track. So here is a diagram that shows the picture with a frame that is the same thickness all the way around. The picture is 7 inches by 4 inches. The frame is to be made out of tile scraps from a recent DIY project. So the picture is a 7 by 4, and they're going to put a little nice tile border around it, I guess, because apparently with leftover tile you can make frames. So let's answer the first couple questions. What is the area of the picture? Well, the area of the picture is 7 by 4, which is 28 inches, or 28 square inches. Okay, so that'll be an important piece to our formula later, that 28 square inches. So then, if the width of our picture is 4 inches, what is the width of the picture and the frame combined? Now notice, in this case, the important part is we do not know the width of the frame. We don't know how wide it is. Alright, we don't know how many tile scraps we have. We don't know how much space it's going to take up. So we don't know the width of the frame. So that is our variable. The width of the frame. I can't spell. So we'll just call it W. So what is the width of the picture and the frame combined? So we're looking at for width. Let's see, so width is 4, that's a shorter dimension, so width is this up and down. You could also call it height. We're not going to do that though. So width is 4. And then the width of the picture and the frame, what would that be if the width of the frame is W? So it would be 4 plus W plus another W. So width total, what is happening? Why is my cursor way over there? Okay, the width total is 4 plus the top width plus the bottom width. So really it's 4 plus a 2W. That's 4 plus 2W is the width. Alright, so that'll be another important piece of our equation. Alright, and what is, oh jeez, this formatting's driving me crazy. Alright. Okay, whatever. Alright, so yeah, the width total is 4 plus 2W, and that is that problem. So we have our width. So now, similar idea with the length. The length of the picture is 7, and the length of the picture and the frame combined is going to be a very similar thing. Again, we don't know the width, we don't know how wide the frame is, so the length total is going to be the length of the frame is 7 plus, again, that width of 7, the whole thing is 7 plus 2 wide, plus the width wide plus the width wide again. So it's going to be, again, whatever the width of the frame is, how wide is that frame? 2 of those. So that is my total length. Alright? So, again, just make sure you're following, make sure you understand where these two expressions came from, alright? Those are some of the more important questions to be keeping in mind. Again, the 4 is the picture width. The 2W is really just whatever, how wide this is right there. Let me see if I can add some text to make this picture better. Hold on. Okay, so hopefully this drawing, or these writings in the drawing, helps sort of show you what's going on if you're struggling. So we have the width, problem 2. I have for color that to be purple, so whatever in the drawing is purple gets you the width. So it's the original 4 plus the width of the frame is W, and the width of the frame is W on the bottom and on the top. So it's a 4 plus 2W. And then the length of the picture is 7. So that's where the teal comes in. The width is 7, and then, or I'm sorry, length is 7. And then W is, remember how wide the frame itself is. Just the frame is W. So I got a 1W over here and 1W over here. So the entire width, let me actually just make another box here. So the entire length is 7 plus 2W. And make that wider. So length is 7 plus 2W. And I'll do the same thing for the width, except I'll make it a vertical text box right here. So the entire width, or the vertical one, would be, let's see, width is 4 plus 2W. And I'll make that a little bit bigger so you can actually read it. There we go. Nope. There. All right. So there is our expressions. So there's the width and length of the whole thing. So we're really just trying to assign values to a picture. All right, it's really good if you can sketch on these things. So if you have a printer, that's a good day to have it. Otherwise, you're just forced to follow along. Another good reason it's a collected only assignment day. So I'm just gonna get rid of the outline because it looks ugly. Okay. So now let A represent the total amount of area the picture and frame take up. So we're going to get to what actually makes the quadratic equation now. So remember, we'll go back to red. Area is length times width. So we want to make sure that we are using our area formula. So if area is length times width, then we want to make sure we substitute in our length and width expressions, because length is really 7 plus 2W. So really I've got, come on now, got 7 plus 2W times my width, which is 4 plus 2W. And if I'm being really technical, well, even slightly technical, these quantities should be in parentheses because it's the entire width times the entire length. All right, so that means I would have to multiply out using my distributive property. So let's do that. Let's go with area equals, sorry, all these 2 columns are really regretting. So area equals, let's see, 7 times 4 gets me 28. 7 times 2W gets me 14W. 2W times 4 gets me 8W. And then 2W times 2W gets me 4W squared. All right. You will actually get an editable Google Doc with this as well. I'll send you a PDF of all this. So you will get a Google Doc that looks similar to this. All right, I'm going to take the columns out though because they're getting confusing. So 14W and 8W combines to get me 22Ws. All right, so there's my area formula. I'm just going to leave this in red. So then, number 5, write an equation. I'm going to the columns now. It's been decided. Okay, hold on. Oh, please hold. So, sorry, this will help me keep track of things better. All right, so we have the total of area as this equation by multiplying our length and our width. So now we're going to write an equation to represent the area of just the frame. And to do that, we're going to remove the area of the picture. All right, so remember the area of the picture from question 1 was 28 inches. Square inches. So area of picture is 28. So we have to do this equation here. That equation here minus 28. All right, now don't be scared, because really, if you'll notice, we have the 28 already in here. The 28 came from the 7 and the 4. It's the same exact 28, so I'm just going to sort of scooch those out of here. But I'll write it in so you remember that it was there. So it'd just be 28. 28 go away, right? Yeah. So 28. So 22w plus 4w squared is my area formula. So I'm just going to change that so it looks nice. Okay, so just to review, we made our area formula, and it came out to this. And then we subtracted the picture, because this is the area of the entire thing. This is the area of picture and frame. So then we have to subtract this. Subtract 28 from equation. Oh my goodness. I always type like that. I mess up every word I type. Subtract 28 from the equation, and we're left with this. All right, which is a more manageable equation. It actually is much friendlier. All right, and we already put that equation in standard form because we're awesome. But yeah, if we didn't put it in standard form, it would have just looked like this, minus 28, and it would have looked like fairly ugly, but that's fine. So if we had a total of 80 square inches of tile to use, so here's where we're really solving equations, because this whole unit is going to focus on solving equations. Today we're going to look at it on a graph, and after today we're going to look at how to algebraically solve it, so without using Desmos. So those of you who don't like Desmos will be happy for about a minute until you realize it's so much easier to use Desmos than it is to use algebra. So, if you had a total of 80 square inches of tiles to use, how could you put this into your equation? So 80 would be the area of the frame, right? So you have 80 square inches of tile to use. So that's like, let's see, 12 inches by 12 inches. That's like less than a square foot of tile. So like you got like a little bit, not very much. So 80 would be the area of the frame. So it replaces the A from the equation. All right, so 80 would replace that A. So I'm going to take my equation, I'm going to backspace that. Nope, get out of here, 8. And say A equals 22w plus 4w squared, but A is actually 80. That equation is the same thing up here. So now what we're going to do is we're going to put this in factored form. And the reason for that is because finding the zeros is really going to be our #1 way to solve quadratic equations, because the easiest problem to answer is what times what gets me 0, because one of those numbers has to be 0. So finding zeros, well, putting it in factored form will be the tricky part, we'll see. Finding zeros is a quite convenient way of solving these equations. So what we're going to do, and here's where our sort of new stuff comes into play here. We are going to solve the equation for 0. Or I might use the phrase set it equal to 0. And really what that means is get everything off one side of the equation. Typically, I like to make the quadratic term positive. So if that's a positive term, just bring everything over there. All right, so that's what I'm going to do. Let's see. So put that in bold and red. I should put in a better color than red because it's like really what we're going to be doing. solve the equation for 0, and which means set equal to 0. So then basically I'm going to do is take this, copy and paste it down here. And I'm going to subtract 80 from both sides, because that'll make the left-hand side 0. So when I put that down there, I'm going to get 0 equals 22w plus 4w squared minus 80. And I'm actually just going to flip-flop these two. I'm going to put the 22w over here. Just flip-flop the locations. I like having the quadratic term first, and that's just how you should write it. Standard form, the technical definition of standard form requires it to be first, but really it doesn't really matter. It's just going to be a lot more helpful to write the quadratic term first. So we're writing that equation in standard form. And then one of the things we're going to learn how to do this unit is write this equation in factored form, which we are not actually going to learn how to do this lesson. I'm going to write it in factored form, and I'm going to show you how factored form helps you find zeros. But again, we're going to look at graphing it today. All right, so let's see. When I write this in factored form, give me a minute actually to do it, because it takes a bit of time to figure out. So that would be 0 equals, let's see, I'm going to take out 2. So 2, and a sort of undistributed 2. And you do not know how to, need to know how to do this. I'm going to write that. You do not need to know how to do the next step yet. So I'm undistributing a 2, so you can follow what I'm doing. Undistributing a 2, so that divided by 2 is 2. 22w divided by 2 is 11w, and 80 divided by 2 is 40. So I did that, and now I have to figure out what the rest of it is going to look like. So please hold. I should have paused the video so I have to sit here and watch me do this. Okay, so we're going to do more of this in the coming days, but really to go from standard form to factored form is one of the, I don't want to say one of the hardest parts of Algebra 1, but it's it takes a lot of like practice, and like it gets interesting. So basically, the start of it was I'm thinking of two different w terms that would multiply to get me 2w squared. So I'd have a 2w and a w for my first numbers. And then my last two numbers have to multiply to get me negative 40. So I'm thinking like, all right, 20 and 2, 8 and 5, 10 and 4. So it turns out that what I turned this into, and like I said, you do not need to know how to do this yet. Like, don't worry about it. The two numbers that work here are 2w minus 5 and w plus 8. This will turn me into this. All right. And so I notice I have 2w times w gets me 2w squared, and the negative 5 and the plus 8 gets me the negative 40. And then I have 2w times 8 gets me 16w, and then negative 5 times w gets me 11w. All right, so I see that I have all those pieces. All right, and the middle term is often the tricky one that sort of throws things. But again, you do not need to know how to do this step yet. I'm just showing you in factored form. So I put it in factored form. And now, if I have the zeros, basically what this means is that I need 2 times something to get me 0. So then either 2w minus 5 has to equal 0, or w plus 8 equals 0. So I'm going to solve both those equations real quick. Hold on. This all goes down here. So 2w minus 5 equals 0, or w plus 8 equals 0. So if 2w minus 5 equals 0, then I know that 2w equals 5, which means w has to be 2.5. So W could equal 2.5. Or I could solve W plus 8 equals 0. And then I could say, all right, well, in that case, W has to equal negative 8. So these are my two sort of zeros. The width of the frame could be negative 8, or the width of the frame could be 2.5. And you should be thinking in terms of context now, all right, one of those numbers doesn't make sense. So do you think the width of my frame is 2.5, or the width of my frame could be negative 8? Well, if I'm going to use all 80 square inches of tile, the width of my frame would have to be 2.5 inches because that's just what I have. All right, I got 2.5 inches. I could use all my tile exactly if I'm very, very careful. If you're working with tile, you're going to have scrap pieces because tile, as I've learned recently, is a terrible substance to work with. So the maximum width I could get out of my frame is 2.5 inches. All right, so those are my zeros. Today, what you're actually going to have on your collected only exit slip, we're going to graph this equation, and look for the zeros. And again, what do the x values represent in terms of the frame? So we're going to look at that. So I'm going to go to Desmos, and I'm going to graph this. But I'm going to take that, instead of 0, I'm going to put in a y equals. So I'm going to copy that. I'm going to go to Desmos, open a new window, because I think I have your form open. Desmos. I'm going to do y equals, okay. For W, I need a square there. Okay. And you can kind of see the zeros there, right? The 0 of 2.5 and the 0 of negative 8. All right. So again, those would be the width values that work in my situation. So the zeros are 2.5 and negative 8. So these are the widths of the frame that would allow, who's this problem about? Nobody. That's boring. That would allow you to use all 80 square inches of leftover tile. All right. So notice the 0 of negative 8 does not make sense in context. So yeah, that happens. A lot of times the negative 0 doesn't make sense, so you just kind of say, well, the answer's got to be 2.5 then, because negative 8 can't be the width. Sorry. I'm just going to preface your exit slip by just going through this last problem, all right? So you got Quinn, who's building a lava pit in his backyard. It's just the colors, so you can clearly see what's what. So we've got a red lava pit in the backyard, and he's going to build a limestone path around the pit. All right, that way you can walk around it and admire the lava pit. So the lava pit will be 12 by 8. And he's going to build a limestone path around it, and notice the width of that path is x again. So it's got the same exact types of questions as above. What's the area of the lava pit? Versus above, what's the area of the picture? And then we have, what's the width of the pit and path combined? The length of the pit and path combined. It's all just following that stuff from before, all right? So it's really just going to walk you through the same type of problem and really just do the same exact things. It's not going to make you a factor because that's just cruel. You're just going to have to do the same exact things. Look at the thing. Look at the Desmos thing. Graph the zeros. What do the x values tell you? All right. So best of luck with that, and I hope today wasn't too confusing.